Good evening, everyone. I will just shout. Is that working? I'm going to let you shout at them.
Hello. Oh, loud. All right. Cool.
You have the.
I do not have the lavalier.
Can I still lavalier for you just so people know that people at home are watching?
Thank you very much. All right. I'm now holding 2 mics. So thank you everyone for coming. It's the March meetup. So I'm hopefully having a good start to the spring. As usual, the very first thing I always do is anyone hiring? Yes, on the couch.
Am I hiring?
Yes.
Yeah, Tamer.
Tamer, what are you hiring for?
Advisor.
Any requirements? Any?
We really like them at PhD.
All right.
There are 4 other types of PhD.
Okay. So Tamer is hiring. So if you want to look for a job at Tamer, raise your hand, and we'll come over to you on the couch later. Anyone else? All right, knock that one out. The pizza today is from Stella's. It's over on 17th Street and 9th Avenue. So if everyone can take their smart devices and go to bit.ly/pizza poll and rank the pizza. We need more data. It's been anemic how many people vote sometimes. Actually, you guys have been doing better about it. So bit.ly/pizza poll, I'll do it right now. Yes, link shortening. And theoretically, this is internet. I'll take you to this beautiful graph here, and you can vote on the pizza. So please go ahead and vote on that pizza and let us know how it is. And yes, that chart was made using R. And the data is available to you. It comes across as the JSON feed. If anyone wants to analyze small data, it's available. All right, after this, we are going to go to Rye House. Who knows what Rye House is? Regulars. All right. Those who don't know Rye House, you walk out the front door of this building, you turn left, just got the door, you turn right on 17th Street. I'm sorry, turn left on 17th Street, and it's on the north-hand side, just like 20, 30 feet into the block. That's Rye House on 17th Street between 5th and 6th, right after we're done here. All right. Next month, we have 2 events. We have the meetup, which will be April 18th. It's going to feature Melissa Donovan talking about HTML widgets. That's going to be yours use HTML widgets, right? So you're going to get HTML widgets today, and you can see HTML widgets again next month from a different perspective. So April 18th. Also next month is the New York R Conference. Who's going? Nice. Very cool. So I highly recommend those of you who didn't raise your hand, check it out. You should really go. It's a fun time. 2 days just nerding out about R. Whereas in the meetup, we do an hour talk and some questions. There, it's 20-minute talks, no questions allowed. So it's a lot of fun. There's 3 talks in a row, then there's food, 3 talks, food, maybe some drinks too. It's April 21st and 22nd. If you want to attend, the URL is rstats.nyc. And if you use code NYHackR, which members of this meetup, you get a 20% discount. Because this is a conference designed for this meetup and to be for the people in this room, so I want as many people to be able to come as possible. All right, this talk, like many of our other talks recently, is going to be live streamed. So if you guys want to watch this in the future, we have 2 opportunities. It's on YouTube and it is on Facebook. We're trying to see which one is better quality. So if anyone's at home, tell us the quality. Those of you folks who are here, I will post it in the comments section, and you will be able to access those videos in the future until one of those companies goes out of business. Up next, we're at a place called Workbench. For those of you who have not been here before, this is an enterprise tech venture fund, and essentially they house companies there, and they invest in some of the companies they offer co-working space to. It's a really cool space. If you have any more questions about it, the people from Workbench are not here today, but the conference is being held right here in this room in a similar layout, so there's going to be 300 chairs. Come to the conference, or just anytime check out Workbench on Twitter or anywhere else, you can come learn more about it. And second to last, we have the t-shirts. Fine, I keep promising everyone will have t-shirts. Joe and Mike, do you want to stand up and advertise a little bit? Show the cool t-shirts? They have the Data Mafia t-shirt, the IR t-shirt, and I just wrote the tag off, the IR New York t-shirt. So if anyone wants them, come by it. Well, then you have to fold it again.
That's your problem.
And you have the IR New York, which violates not 1, but 2 trademarks. But But it's like open access commons or something like that. It's parody, so you can't get sued, right? And we don't make a profit, so that's even better. If you want to buy one later, come talk to Joe. I don't hit anyone with that. We'll be selling it afterwards, and we sell them just above cost to make the money go into the meetup. With that, I think that was the last one. Do we have any announcements from the crowd? Any cool events happening this summer, maybe?
Hi everyone, my name's Emily. Part of the Our Ladies group. We're planning a tutorial series for the summer. This is open to everyone. The tutorials are going to be independent from one another, and we'll start with an introduction series. So especially if you have any colleagues who are interested in learning R, or you're an R vegan yourself, I think this would be a great opportunity. I'm going to post a link in the comments section of the meetup, or you can talk to me if you're interested in learning more.
Any other announcements? With that, I'll turn this over to our speaker, fresh off a plane, not that fresh, but recently off a plane from India. So it's been 2 days though, so he should be completely acclimated. It's been a day and a half. He's good. He's cool. He's our second-time speaker. This is a couple years ago. He's been here for a long time, and he's going to talk about Trelliscope, a way of visualizing mass amounts of data. So, round of applause for him, please.
All right. Well, first of all, thanks to Jared for arranging this, and thanks to Workbench for hosting. I'm really excited to be here. I'm curious, how many of you were at my talk 2 years ago? A handful. Okay. So I talked about several things last time. One of them was Trelliscope. I talked about a little bit, but what I'm talking about today is kind of newer, and it kind of fits into your analysis pipeline a bit differently. Also, was anyone at the R Studio conference this February? Okay. Were you at my talk?
I missed your talk.
Okay, yeah. Well, that's actually a good thing, because this is actually a kind of extended version of that talk, so I just recorded it. I was going to email it. I guess, you'll see this link down here. I should make sure that you can see things okay on that screen. These slides are live on the web, so you can look at them later or follow along. All of the examples actually run live in the browser as well. And I'm sure I can have Jerry post it to the meetup, or you can follow me here on Twitter. I'll post a link to these things as well. But yeah, so I'm going to be just focusing solely on a project called Trelliscope.js. I guess I should say a little bit briefly about myself. I am from Washington State, and I'm just over on this coast for a few things, and so it worked out for me to come speak here. And I'm primarily a statistical consultant, and I really enjoy, writing software, open source, and so I do that as well. I used to have a funding source that paid me to write open source software, and I don't quite have that anymore, but I still do it. I still enjoy it. But primarily, I'm a consultant. I'm also an adjunct remotely at the University, just working as the graduate students there on some of the topics that I'll talk about today and other related topics. But this talk is really mostly just going to be hands-on and hopefully just an introduction of some tools that might, be beneficial to your workflow in terms of data exploration. Okay. So you can run all the examples in this talk if you'd like. This is the code to be able to do that. Okay. So I want to start out just by saying, what in the world is this weird name, Trelliscope.js? It can be described in several ways. First of all, it is an HTML widget. How many of you are familiar with HTML widgets? Okay, so an HTML widget is basically an R binding to some JavaScript library that allows you to make cool, usually visualizations, sometimes other htmlwidgets.org if you want to learn more and see all the widgets that are there. There's actually a gallery of widgets there that you can look at to see what's available. But it's an HTML widget. It turns out that it's an HTML widget where I actually wrote the JavaScript library and the R package as well. And I'll talk about what that package does in a minute. You can also describe Trelliscope.js as a layout engine for collections of plots or HTML widgets. So suppose you've got an HTML widget, you want to make it for a bunch of different pieces of data and lay it out. You can use Trelliscope.js to do that. But the way I would like you to really think of Trelliscope.js is as a framework for creating interactive displays of something called small multiples. Anybody heard of small multiples? Okay, great. If you haven't, that's fine because that's what I'm going to talk about. So, small multiples is a term that I think, I don't know if it originated from Edward Tufte, but he's the one who kind of talks about it in his books. But the idea's been around for a long time. It's a very simple idea, which is if you've got a lot of data or a lot of variables in your data, then often a very effective way to visualize that data is to break it into pieces and make the exact same plot for each piece of the data and arrange them in the grid and look at them. It's a really great way to visualize data, and I'll talk about why in just a minute. But I found a very timely, well, maybe I'm about a week late on this, example of a small multiple plot showing the, I don't know if you can see the text, but the difference in tax credits under Obamacare versus the GOP. And so they're breaking down by age group and by income group and showing what groups are affected positively and negatively by that proposed plan. But this idea was kind of formalized and popularized with the lattice package in R. Actually, the trellis display system came out in the 90s with S++. And then, if you use ggplot, the idea of like faceting your data in grounded graphics. Okay, so why are small multiples useful? One thing is that they avoid overplotting. If you've got a lot of data, a lot of variables, and you put it all on the plot, it can be, stuff can cover up other stuff, and you can't really tell what's going on. But really, one of the important things here is that our brains are really good at perceiving patterns. And when we're looking at multiple plots of something where we know what the plot is, it's the same plot for each piece of data, it's just the data that's varying. We can very quickly pick out things that are different. And it's a very useful thing to do. So I have a really silly example here, something, actually, showed this to my 4-year-old, right? And she can just immediately, obviously pick out on each row. It's hard to tell on this row because the color of the monitor, but there's a different color snowflake there. But the idea that our minds are very good at picking out very quickly without even thinking things that are different. And so it's kind of an advantage of the idea of small multiples. And just, this is kind of a softer argument, but in my experience of visualizing data, I found it to be kind of a go-to method for visualizing data over and over again, usually much more useful than like animations or like paint brushing and things like that. I'm not saying those things aren't useful, but things like animation can be really interesting to see how something's like changing, but you can't compare frames in your animation, so you can't remember what happened, a second ago. And custom interactive visualizations are really nice, but usually take a lot more work to create. And so I'm going to show you how we can create small multiple displays very easily, which is another plus. Okay, so what is Trelliscope? So I mentioned Trellis Display. Trellis Display came out of a paper from Bill Cleveland and Leonard Becker at Bell Labs in the 90s, I think 1996. So Trelliscope is just kind of a play on that, where we're talking about the idea small multiple displays work and make sense when we have a small number of subsets we can put them on a single page. But what if I have a lot of data and a lot of subsets that I want to look at? Or I want to be able to kind of interactively arrange things as to how I'm looking at them. And so our solution for that is something called Trelliscope, which is a software system that takes the idea of conditioning, faceting, making separate plots for different subsets of the data, but then giving you the ability to interactively sort and filter a page through different panels of the display interactively. And the way that we do that navigation is through this kind of silly term agnostics, which are metrics that are computed about each subset that say something interesting about that subset and therefore allow you to interact. And I'll show you examples of these when we get there. So Trelliscope.js, as I mentioned, is a JavaScript library. So Trelliscope has existed for, the idea has existed for probably 5 or 6 years, but it's evolved. It started out as a really crappy JavaScript library, then Shiny came along, and it became a Shiny application. And then web technologies kind of really evolved and started to provide a lot of power to write an application purely in JavaScript, and therefore not requiring like a special server for a Shiny application and things like that. And also just allowing kind of a more robust and well-accepted platform for other developers to get involved. So this is just fresh in the last maybe 6 months that I've rewritten Trelliscope as a package called Trelliscope.js. And Trelliscope.js lib over here is a purely JavaScript library that in theory could be driven by any language, not just R. And then the R package, Trelliscope.js, basically provides an interface where from R you can interactive Trelliscope displays. I'll just mention as this historical note that all of this evolved from a project that was funded by DARPA. This was my project that allowed me to work on open source and get paid for it, which was really awesome. And this DARPA program was called the X-Data program. It was kind of a cool new idea of like funding open source data science software. There were some really cool projects there. Continuum Analytics, Anaconda and OK, and lots of other cool themes were there. Spark was actually funded by this program as well. And we were one of the sole like R representatives in this program, so that was kind of fun. But that was a lot more big data focused, and that's kind of where the ideas for Trelliscope came along. And I'll actually show some examples of some slightly large data sets in a minute. So I want to show you an example of what Trelliscope is, what it can do. And so we're going to use the Gapminer data set. This is available in an R package called Gapminer. And what it provides is a few variables measured over time for a lot of countries in the world. So things like life expectancy and so forth. So, you might ask the question, I want to explore this data, I want to look at what mortality looks like across time for each country. And so you might make a plot like this. So I'm assuming some familiarity with ggplot throughout this section. But basically I'm saying I want to plot my life expectancy versus year, and I want to color each line by country. And I'm kind of being a little over the top here with this example, but I get a legend entry for every country, and I just get a blob of lines that I can't really do anything with, right? So that's overplotting. Now, I could instead group by country, but only color by continent, so that kind of cleans up my colors. And this is a little bit more useful because I can kind of see that, Europe is up here, here, and I see some outpipes sticking out, right? But there's still a lot of overplotting going on. So I can see some things going on, but there's still a lot of overplotting. So I'm not saying this is not a useful plot. This is a useful plot, but I'm saying there's more we can get out of this data and how to visualize it. I could also facet. So I'm using this facet wrap function in ggplot to facet by country to help kind of split things apart and get a better picture of things. I can also use like an interactive package like Plotly. If you're not familiar with Plotly, Plotly actually has an interface for taking a ggplot object and turning it into an interactive object in the browser. And what's nice about this is I can now like hover over lines and actually see like who is this guy right here. This is Rwanda that Montalvo jumped down in the early 90s, right? And I can do the same over here with this, right? So this is useful, right? I'm adding some interactivity without much trouble, and it allows me to hover over and see what some of these weird lines are. But there still is overplotting going on, and it's kind of, it takes work for me. I actually have to go and hover, and I can only see one thing at a time that I'm hovering on, right? Okay, so here's another option. I could facet on country, right? Can you tell what's going on? No, right? There's too many countries to show up on the page. Okay? So I'm obviously leading into something here, but so one of the nice things about the Trelliscope JS package is it actually plugs directly in. There's different ways you can make displays, but one of the ways is that you can plug directly into the ggplot interface. And so if I have a ggplot2 plot and I want to make a Trelliscope plot instead of a regular faceting with ggplot, I can take anywhere that I use facet wrap or facet grid, which are ggplot2 functions, and just replace them with facet Trelliscope. Okay? And so I'm going to take this same set of code here before, but I'm going to change facet wrap to facet Trelliscope. I'm going to add a few other arguments that are optional, saying, by default, how many rows and columns I want, and what the width of the plot should be. And what comes up is this plot here. But what's nice about it is, and can you see it okay? Like, roughly. Yeah, the font's a little small there, but basically it's showing each country and continent. And by default, I'm ordering by country and continent. And like I said, you can play around with this on your own later. I'm going to open it in a new window so that it fills up more screen real estate. And maybe I will change the grid. Okay, is that better? Okay, so does this kind of give you an idea? So I have a grid of countries, but I'm not looking at them all at once on one page. I could specify that I want to look at them all on one page, but what I get is this interface where I can say, I have 142 countries. I can click the arrows here or use my arrow keys on my keyboard to scroll through and look for patterns. And it actually is a bit more useful to see more at once. So just look at the dots. Okay, and you can see now I'm sorting by country first and then continent by default, and that might not be that interesting. Right? I might want to sort by continent first and then country. So I have an interface here. Actually, maybe I'll make that a little bit bigger. Is that any better? Okay. So I have these options over here, these interactive options for how I navigate these panels in my display. One of the options is sorted. So right now I'm sorting first by country and by continent. So I can change the direction I'm sorting, or I can just get rid of my sorting variables altogether. And so I might say, I want to sort by continent, and then within continent, then by country, right? So now I'm looking at African countries. And I'm looking alphabetically, so I've got Africa, and then Algeria, Angola, and so forth. But maybe I'm not interested in the country, maybe I'm interested in the mean life expectancy. Okay? So all of these variables that you see right here are variables that it found in my data when I made the plot and said, hey, these variables are here, I might as well compute statistics about them that allow you to navigate your displays. Does that make sense? And so life expectancy was one of those variables that was in my data that I passed into ggplot, and so it says, I'm going to compute the mean life expectancy for every country and make that available as a variable that you can sort and filter. So now I'm sorting from mean life expectancy low to high, and so I can see within Africa, Sierra Leone has the lowest average life expectancy. And I see like Rwanda, as I saw before, having this drop down, right? But I see some other countries that have a dip as well, a little bit later, like in the 2000s, that I didn't see before when I was plotting, right? And I see some other interesting things, like some countries have this where there's a little drop, like almost a discontinuity, right? And so hopefully this illustrates not only how easy it is to take something that was just a regular ggplot faceted plot and turn it into something interactive, but also how this can be an additional useful way to visualize data. Another cool thing is you can actually, since Plotly converts ggplot objects to interactive JavaScript visualizations, Plotly is another HTML widget. And I mentioned at the beginning, you can think of Trelliscope.js as an HTML widget layout engine for other plots or HTML widgets, right? So here I'm saying as Plotly equals true, and what that does is it makes each panel here an interactive Plotly plot. So now I get like tooltips automatically and things like that, which is really fun, right? I'll show you some examples of using some other HTML widgets as well. Okay, so that's a fairly straightforward way to make interactive faceted displays using ggplot. Now I want to shift gears to plotting in the tidyverse. Is everyone familiar with the term tidyverse? Okay. Tidyverse is basically a collection of packages, pretty much all authored by Hadley Wickham or contributed to by Hadley Wickham, that kind of comprise a lot of like best practices and just simple ways to work with data. So things like dplyr is in there, tidyr is in there, a lot of packages. So there's actually a package called tidyverse that you can install in R that basically installs all of the packages that are inside of the tidyverse. A really good resource for learning about this is actually this book that I linked to down here, R for Data Science, which is by Garrett and Perlman and Hadley Wickham. You can actually access freely online. It's a really good book. And the idea I want to get across here is to, the title of this talk, the subtitle is Plotting in Tidyverse. ggplot is actually a tidyverse package as well. In that book, they introduce this notion that I think is pretty cool, which is the idea of what's called list columns. Okay, so they're using the gapminder data, which is convenient because that's what we use already. But they're saying, suppose for each country, I want to fit a linear model to my data. Okay? And so they're using, the group by function in dplyr and s to basically create subsets of data for each country. And then they apply this country modeling function that basically just computes a linear model for each country. And it creates this result here, which is a data frame, but with some really weird columns in there, right? So country, continent, those look normal, right? Those are just strings or factors, I guess. But I have these two weird columns of data and model. And what's happened here is, since I've grouped and nested my data, I now, instead of having, how many rows did we have before? 1,700 or something. Right here, we had 1,704 rows in our data frame, and that included repeated rows for countries, right? Because I'm measuring them over multiple years. But here, I have 142 rows, one row per country, which is a convenient way to represent my data if I'm doing a by country type of analysis, where the actual data for each country is stored in this column called data. And it says this is a list. It's a list column, and it's basically a nested data frame. So within this column is the data frame of the data for Afghanistan. And this cell of the column is the data for Albania and so forth, right? And then also my model that I fit. When you fiddle in your model, it returns this S3 object, and so I'm just storing the model fit result in another column. Okay? So it's kind of a convenient way to keep track of things, because now I can say, show me, and I also computed the residual median absolute deviation. So now I can easily say, filter out countries that had way too high of a residual median absolute deviation, and then let's do some stuff with those, right? And I can treat it like a table, and it's all nice and convenient. Does that kind of make sense? So in our Delta Row project, we kind of were doing this notion not in quite such a clean way. And when I first saw this, I was like, well, that's just kind of weird, but I really like it now. Once you kind of get the idea. Okay? So actually, in the R for Data Science book, they compute this model, and then they want to visualize the model fits, the model results, right? And they actually, say, how can you plot a list of data frames? And they say, well, let's not worry about that. Let's, compute the residuals and turn the residuals back into a data frame and plot them in a single plot. Okay. And so what I'm going to talk about is actually answering this question: how can we plot a list of data frames? Okay. So before I tell you how to do that, let's actually make a plot for a single subset of our data. Okay. So I have this data set called by country, and it has one row per country, and it has this column data and model. Okay. And so I'm going to write a function that takes the data and model from one row of my data set and make a plot for it. And here, just to introduce another package to you, which is actually a package that I've authored. The R-Bouquet package, it's a JavaScript plotting library that is an interface to the Bouquet plotting library, which is developed by Continuum Analytics. And so what I'm doing is I'm making a function that says, hey, plot my actual data at this point, give me some tooltips for that, and then, plot the fitted line as well. So it takes data and model as arguments, and with this code right here, I'm testing this function on one subset of my data, basically the first. So this is Afghanistan. I'm just getting the first this item of data model. Okay. So my answer to this question here, how do you plot a list of data frames, is to simply compute an variable that is a list of plots. Okay. So now, each country in my data set has its raw data in the data frame, its LM result, and a plot object. Okay? And if you've done that, you maybe can imagine where we're going next. I have a bunch of plots, and they're all specified as a column of my data frame. And now all I have to do is send them to this function, Trelliscope. And Trelliscope magically takes care of things. It says, oh, there's a column here that has plots in it, so I'm going to plot those. And it will actually look at any other columns and say, oh, I'm going to turn those into prognostics or metrics with which I can sort and filter the panels in my display. So in the R for Data Science book, they pull all the residuals back and make a single plot of them. Here we're plotting actually the fitted values for each individual country, which can be a useful thing to do. And I can now do things like I can sort on my residual median absolute deviation, and by default it's going from low to high. I'm going to go from high to low and see the countries where my linear model is doing terribly, right? It's not capturing what's going on. This is a useful way to kind of drill in on that. I just realized I didn't show the filtering functionality, so I might as well show that real quick. So there are other functions that are interactive, I guess, modules along the left side of this. That's not good. I can't even see it. They show up on my screen, so hold on. Is that better? Okay. So I've got buttons here. I have grid where I can specify the layout of how I'm looking at things. I've got labels, which I can turn on and off, like any labels. Maybe I want to see the mean life expectancy show up beneath each of my blocks. But a really nice feature is the filtering, right? And so I can actually look at the distribution of my median absolute deviation of residuals, for example, and I can interactively say, you know what, I want to filter out just the ones that are, 5 or bigger, for example, or I can look at the ones that are small, right? Or I might say, I want to look at only Asia, and you'll notice that all of these distributions are kind of, conditional and update as I filter. So when I filtered on Asia, you'll see that the residual median absolute deviation distribution changes, and I can actually type things in here as well. We'll see some more examples of that. Question?
Yeah, that's available for any telescope.
Yes.
It has nothing to do with our
No, yes, good question. Yeah, all of these controls are available with any Trelliscope display. You are only limited by what variables you don't specify for it to sort and filter on cognostic, basically. So any columns that you add into the data frame that you pass in here will be available as metrics to interact with. So I'll show you some more interesting examples.
Yeah, just wondering, is it possible to choose, let's say, specific countries instead of just sorting the countries and columns, and have just like side by side with the
Yes. Let's pick a couple countries. So there's only one country per observation here. So my country distribution here just looks like uniform, right? But I could either say I want to do India and Angola or something like that, right? And I can compare them. Or another thing I can do is I can actually type things in like here. So I type IN, it will pull in everything with an IN. If I type IND, I'll get India, Indonesia, stuff like that. So you do have control. And these are regular expressions, so if I wanted anything with IND or A, N, G, then I get India, Indonesia, Angola, and Bangladesh. So does that kind of answer your question? Cool.
What's a cognostic?
Yeah, so cognostic is just a fancy term for any of these metrics that we compute about each subset that allows us to sort and filter. So the term originated from John Tukey, who, he was, back in the early days of computers, I think in the 80s, he wrote this paper talking about the idea of cognostics. Basically, I guess he was known to make a lot of plots, print out a lot of plots and take them all over and look at them. And he said, you could imagine in any analysis generating an enormous number of displays, and so we need a computer to guide us. We need computer-guided diagnostics, so we call them diagnostics metrics to help us navigate the space of a lot of plots. And he probably had something more like AI-ish in mind, where the computer automatically says what's interesting about different images. And I think there's some interesting work that could be done there, but we kind of use it in terms for any just think of it as some statistics, really, or any attributes about a subset that you can do something useful with.
Is there a term for computing metrics between prognostics?
No, but I think there's some interesting work to be done there. There's another interesting term called scagnostics, which is scatter plot diagnostics. And there's actually a scagnostics package in R that will take a scatter plot and compute 8 different metrics with really kind of funny names that tell you how clunky, on a scale of 0 to 1, your scatter plot is, and things like that, which can potentially be useful. Any other questions? Okay, so just to recap, plotting in the tidyverse. The idea is basically to create nested data frames using group by and nest. And then, if you're familiar with, I never know how to pronounce it, P-U-R-R-R. How do you say it?
It depends if you have Hadley's accent.
Maybe that's why I haven't really figured out. Okay. There's map functions in the per package that allow you to say, I want to compute this on each element in my list and return a character vector, or so it'd be map underscore CHR, right? And so we have functions map underscore plot, and all in that family that say, I'm computing a plot and returning that as a list of plots that Trelliscope knows that I can display. And then we can optionally add more columns to our data frame, like our residual median absolute deviation that we had added, automatically available as a diagnostic. And we can use map underscore cog functions as well to, basically compute across all of our subsets and compute additional metrics that might be interesting. Okay. So, any questions about plotting the tidyverse? Okay. So that's kind of, yeah. Yes. So that's actually a really good question. The question is about how these things are shared, where the data resides, and things like that. And that's actually one of the reasons why I migrated to a pure JavaScript solution, because all of these plots that you've seen so far are kind of just put out into a self-contained directory on your computer with an index.html file that you can just zip up and send to anyone and it will run without a web server or anything like that. Which means you can also post them very easily on the web. So all of these plots are actually just hosted on GitHub. I just committed them to pages, and I'm just sticking them in here in an iframe. GitHub pages was actually down this morning, so I was really worried that the top of this thing actually burned. So it's easy to share and host. Now that might bring up the question, well, what if I've got like 1 million subsets of data? I'm going to zip all that up and send it to someone, right? And so that's something that we're working on right now. It's something that existed in the previous Trelliscope package, was this notion of rendering your plots on the fly. Right now, all your plots are rendered when I create that list column of plots. And you can imagine that can take some time if I've got a lot of subsets. And so you might say, you know what, I just want like a promise to create those plots in my column. And then when someone goes to the display, it says, I want to look at these 8 countries right now, so grab the data from those and make the plots on the fly. That requires a server right? Because you've got to have a data sitting somewhere. And so there's actually various solutions for that. Some of them fairly straightforward from doing within R, but none of them are straightforward for sharing those. You need to have a special server set up for that. So, yeah.
The goal is to eliminate Excel from the analysis, so it could be all server side. When you think about that, the filtering, metrics, and aggregation, can you think of this as a potential solution for that?
To replace Excel.
At least from the perspective of pivots and taking data and exploring.
Yeah, I guess from an exploration point of view, for sure. In terms of, all of it, I guess the thing to keep in mind is all of the plots are pre-computed and all of the prognostics are pre-computed. And so anything that you saw in that filter sidebar is stuff you can do, but anything beyond that is kind of not built in yet. There are actually additional functionalities that we're hoping to build in terms of more rich filtering for different data types and things like that.
So the Excel pivot and the filtering side will allow for complicated filtering across many variables. Would that functionality exist?
I guess. I mean, so when you're doing the filtering, the notion of all of these distributions being linked to each other may take care of some notion of that, like aggregation as you cut across different filters and things like that. But it may not be presenting itself as output in the way that you would expect or thinking of in Excel. I'm not sure. I haven't used Excel for a while, so. Any other questions? This microphone sound, I feel like I'm like, I don't know, it sounds like a radio putting you to sleep type. But, yeah.
Can you put I'm not quite sure what I want to, but just out of curiosity, can you put regular ggplot into a list?
Yes. Yes. So the question is, basically, do I have to use Trelliscope to get ggplots? No, you can do it this way as well. So basically, your function here, this function I made right here that makes a plot, you can stick any R code in there that makes a plot. Actually, you can't do base R graphics because it needs to return an object, but you can put lattice in there, you can put ggplot in there, you can put with I won't say with 100% certainty you can put any HTML widget in there because different HTML widgets have different layout issues that may crash and burn inside the Trelliscope display. But most HTML widgets that I've used as plot list columns have worked. So,
Would properly as well, I guess, write the same idea?
yes, yeah. So right here, I'm just creating an RLocate object. You can create a plotly object in there. And I'll actually show you using like the Viz network just for the heck of it, HTML widget here in a second as well. Okay. So I want to point out another nice thing you can do, which is you can actually just point to URLs as images for your panels, which is nice. And this is a silly example, but I did it because my kids really liked it. And I'm always trying to make what I do for my kids because they seem to not think it's cool. But I've got this Pokemon data set, okay? And what this has is 801 Pokemon, which I don't know enough about Pokemon. I don't know if that's all of them or most of them, or it's like different generations and things like that. But I've got all of these different metrics, their height, weight, base experience, type 1, type 2, attack, all this stuff, okay? And what's important is I have this URL that points to an image for each Pokemon, okay? And what I can do with Trelliscope is I can actually just very simple, basically one-liner, okay? So I can say, pass my Pokemon data set into Trelliscope, And it knows that there's that URL there that I've specified, and so it renders that as my panel. And so it's actually going and fetching these images, right, from the web. And so what's cool now, and I'll open this in the window, make it a little bit bigger, is, you can now quiz yourself on how well you know Pokemon. So, for example, you can say, I don't know, who's the heaviest Pokemon? Or the lightest? The heaviest is Groudon. Probably saying that wrong. Okay? But you could also say, well, who's the heaviest within, I don't know, generation 1. Okay. And I have too many labels here, so you can see sometimes, I'm going to get rid of weight. Oh, Snorlax, right? Is that who that is? Yeah, Snorlax. Okay. So it's kind of silly, but it shows you like this. You can think of Trelliscope as kind of a database of images that you can play, right, in various ways. Okay. But another really nice thing about being able to use URLs as panels in Trelliscope, this actually came up from something that Jared was asking a little while ago, which is any type of REST API that you have that serves out images. If you don't know what that is, don't worry, but if you do, you might appreciate this. Can be used in a Trelliscope display. So Jared had someone that they had images stored in Elasticsearch, and they wanted to see if they could put them in a Trelliscope display. Well, Elasticsearch has a REST API where you can just say images here, and Trelliscope will fetch it and render it. Okay? So that's actually one way that we can do a Trelliscope displays tied to a server, just through REST APIs. Okay? So, like there's an R package, Plumber, I think it's called, that allows you to easily create REST APIs, and so you can very easily, have server-side Trelliscope displays to do that. Does that make sense? Yes.
What if you have multiple columns of images or plots? How does Trelliscope which one to choose? Just chooses the first column?
That's a good question. Yes, so it chooses the first column that it can identify as something that it can plot, unless you specify the column name. There's actually an argument in Trelliscope to say what column name to use as the panel, but just make it easier on you if you know you only have one, then you don't have to specify it. But that's a good question. Any other questions? Okay. I think I'll just a couple more examples. Oh wait, I'm not in my slides anymore. It's kind of fun to look at these. Okay. Okay. So here's another example of HTML widgets as panels, just to show that panels can be anything. So I just made up some network data. Some of the consulting I do is for cybersecurity and network analysis type stuff. And so you might think of having a network of nodes, and you've got data collected on whose different nodes in your machine are talking to or something, right? I'm not necessarily saying this is a useful way to look at it, but it's just an example. But there's an HTML widget called BizNetwork that allows me to make interactive network plots. And they have this kind of drop-down where I can go through and select different host IDs, and it will show me who that node is talking to. And you can probably see where it might go. Trelliscope display of this, where this is nice to have a drop down and be able to click and choose, right? But it'd kind of be nice to see all my options at once. And so this is a lot of code. You can play out what that's doing on your own if you want. But basically, I'm doing the same thing as I did before, where I have a function network plot that takes, data about each of my subsets in and spits out a BizNetwork object. And so really all I'm going to do is take my data, group it, and apply this network plot to my data. I won't go into the details, but it's creating a panel column that is an S3 BizNetwork object And so now all I have to do is pass that into Trelliscope, as you've seen before, and I get something like this. Now, something I failed to mention before is I can use dplyr functions like arrange to kind of pre-specify the way I want things ordered, which is kind of nice. So I've got my data frame of nodes, and I can say I want to arrange it from number of nodes, high to low, and then pass into my Trelliscope. And you'll see my default filtering here is you probably can't see that very well, but it's the number of nodes. Decent. Okay. And so now I can go through this, or I can say, I don't want to filter on number of nodes. I want to filter on the total connection or something like that, from high to low. And so now you can imagine there's all kind of graph metrics you can compute about connectedness and stuff like that that might give you really nice ways to look at the different nodes in this network. Okay, I was going to show you, we're probably getting to about time here. So a couple other examples. If you've seen me talk about Trelliscope before, you've probably seen this example just because I like it. It is the average list price per square foot versus time for monthly for homes being listed in the United States per county. And so I love to show this one in New York because if all I do is sort the list price, guess who's number one? New York County. Okay, and you can see the trend of what's been happening. You're up over $1,800 per square foot list price now in New York County. The second one, so I'm sorting, right? The second one is Pickens County, which I think is where Aspen is in Colorado. And it's interesting that that's the second highest, but it's had a very different trend than New York County, right? So it's kind of fun to go in here and I can maybe I'm going to kind of load up the county in Washington. So I can say, I want Benton County in Washington, and we're going up, but we're like around 130, 135 right now. So, but we have no culture. There's a trade-off. Okay. And another one, just to show that this can scale. Don't be scared about this one. You see all this Arabic and stuff. But this was actually from a DARPA challenge. DARPA would have us go every through these kind of hackathons, and one of them was, we've got all this Instagram data, and we want you to see if you can, make tools that allow us to look at that data and see if we can find Instagram posts that indicate violations of the ceasefire agreement in Yemen. Okay, and so Trelliscope seemed like a nice tool for that. Here we have 15,000 Instagram posts, and we can, it's really responsive, even with 15,000 posts, where I don't know Arabic, but we have like keywords here. Bomb, right? So I can look at all the posts with bomb, and if there's one that looks interesting, I can actually create cognostics that are links to other things. So, maybe I should have scripted this so I actually found one interesting. This is always, there's supposed to be filters, but they don't work very well, so I should be showing a slide in case something not so nice shows up. But so here I actually can take a post and go directly over here to Instagram and do then I can do like a Google Translate on that page and check if it feel what's going on. So kind of again, just to show that it can be a nice tool for any like most large data sets kind of have natural ways to be broken up, right? Media posts or maybe user patterns of posts, right? There's many different ways to divide and utilize your data to hopefully get some insight. Okay, one last idea that I want to get across is, and I think this kind of came up in a question, is Trelliscope kind of came about as like a tool for the data scientists to help the data scientists explore the data. but we found it to be really useful as experts and try to go back and forth and understand, if they have some interactivity, we can create these interactive things without too much effort or too much expertise in interactive visualization. And so we can actually use Trelliscope to create applications for people to play around with, not just yourself, right? You could argue, well, yeah, there's an interface to get used to, but once you're used to that interface, any other app you give them, they kind of know how to use already. They don't have to worry about a new interface every time. But an idea to make it across here is, if you ever found yourself making a Shiny application that has a bunch of different buttons and knobs and creates a single plot output, you could easily cast that as a Trelliscope display, right? Because all those buttons and knobs can become just a data frame of parameters, and then the corresponding plot for each of those parameters. And what's really useful about it is, again, I have a really silly example here of a Shiny application. This is the code for the Shiny application. It lets you pick a country and look at the data for that country, right? It's not updating them. Oh yeah, it's okay. Now, what's maybe wrong with this? You're only looking at one plot at a time. Remember we said it's kind of hard to be able to look at multiple things at once. And so this is like a prime example of if you made an app that did something like this, to say, well, it's probably even a lot easier to just make this into a Trelliscope display. Right? Okay. And I guess finally I'll just mention about scaling Trelliscope. So the previous version of Trelliscope was the Shiny app. We were in this big data program with fixed data, and we wanted us to be able to visualize really large amounts of data. So we kind of put a lot of emphasis on that with the previous Trelliscope application, and then we found that we were the only one using it for that purpose of hundreds of gigabytes or terabytes of data sitting on Hadoop. And so it's kind of like, why work so hard to maintain this for ourselves? And so we that's the reason why I rewrote Trelliscope.js with more of the idea of how can we make this really seamlessly fit into existing workflows, and then worry about scaling later if it really is important to people. But you saw an example of 15,000 panels and it worked just fine. But we have in the past had million panel displays with the previous version of Trelliscope that are linked directly to Hadoop, where we don't pre-render the panels, we